we've worked with the Pythagorean theorem a couple of times already. A squared plus b squared equals c squared. There's a little bit deeper with Pythagorean theorem is Pythagorean triples, which oftentimes when you're doing the Pythagorean theorem you get square roots, but there's special cases where there's no square roots for any of the sides. And they are useful and common enough that it's worth kind of remembering a few of them. One set is called the 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. So that is a Pythagorean triple. If those are the three sides, it works out for your Pythagorean theorem. Another set of numbers that works is 5, 12, 13. 5 squared plus 12 squared does equal 13 squared. Another one is the 7, 24, 25. Same thing, 7 squared plus 24 squared equals 25 squared. And then the last one that I'm going to list right here is 8, 15, 17. 8 squared plus 15 squared equals 17 squared. So there are whole numbers that work for the Pythagorean theorem. Now, one thing with all of these Pythagorean triples, if you double all the sides or multiply all the sides by 3, they're still Pythagorean triples. So if you double all the sides, you get a 6, 8, 10. It's still a Pythagorean triple. 36 plus 64 equals 100. Even if you multiply it by 3, 9, 12, and 15, that's still a Pythagorean triple. So they kind of fall into families. There's the 3, 4, 5 family, the 5, 12, 13 family, the 7, 24, 25 family, and so on. So there's an infinite number of Pythagorean triples. These are just the different families of them. So all it is really just a shortcut. 18, 24, so you can figure out the third side. Now 18, 24, that's not one of these listed. There's nothing with an 18 in it. But you could probably reduce this to figure out if it's one of these other families just with a multiplier. So 18 and 24. 18 is 6 times 3. 24 is 6 times 4. So we've got that 3 and the 4, which means the other side is 5. 3, 4, 5, Pythagorean triple. But we had a multiplier of 6, so it's 6 times 5, so this side is actually 30. So if you can just figure out what number they have in common, the common divisor for the two sides that they give you, you then break it down to one of these Pythagorean triples with just a multiplier, whatever that number is. So here we've got hypotenuse is 68, and the shorter leg is 32. We can try to simplify those, like I said, by looking for a common factor. For 32, if we divide by 2, we get 16. 68, we divide by 2, we get 34. We can divide by 2 again to simplify that further. We get 8 and 17. You get 8 and 17. So we divided by 4, essentially. 32 divided by 4 is 8. 68 divided by 4 is 17. So that means our multiplier is 4, and our Pythagorean triple is the 8, 15, 17. 8 times 4. The other side could be 15 times 4, which is 60. And then the last side was 17 times 4. So you just have to simplify, figure out what your multiplier is, and pick it up from the Pythagorean triple. Just a good shortcut for Pythagorean theorem. So related to the Pythagorean theorem, You can solve, give you a ratio like sine equals 3 over 5. You can find the length of the third side because really they're telling you information about a right triangle. Draw a right triangle. They're giving you information about a right triangle. So we've got this angle here. And it's sine, which means opposite over hypotenuse. So from what they give you, fill in the opposite side and the hypotenuse. Opposite is 3, the hypotenuse is 5. So if we have those two sides, you should be able to recognize that the missing side is going to be a 4 because it's a 3, 4, 5 triangle. And then kind of scrolling down a little bit here, now we can write cosine and tangent for that same angle. Remember, cosine is adjacent over hypotenuse, so that would be 4 over 5. And then tangent is opposite over adjacent. Opposite's the 3, adjacent's the 4. Opposite's 3, adjacent's 4. So if they give you a ratio, you can find the third side and then write the other trig ratios. So we have a similar question here. You can draw your right triangle. Cosine, so adjacent is 5, and the hypotenuse is 13. So that missing side, 5, 12, 13 is a Pythagorean triple, so that missing side must be a 12. So then we know the entire triangle. We can write sine, which would be opposite over hypotenuse, 12 over 13. And then tangent will be opposite over adjacent, 12 over 5. So for tangent, we have 7 over 24. That's opposite and adjacent. Opposite and adjacent. That's another Pythagorean triple. 7, 24, 25. 7, 24, 25. So that means sine, opposite over hypotenuse. Opposite is 7, hypotenuse is 25. And then cosine will be adjacent over hypotenuse, so it's 24 over 25. So we've got almost the same question, except this time we have a 3 and an 8. There's no Pythagorean triple with a 3 and an 8 in it, which is not a big deal. This is opposite, this is hypotenuse, so you fill it in, 3 and 8. But then rather than knowing the third side automatically, we just have to solve it. Since it's not a Pythagorean triple, we don't know it, we have to solve for it. So 3 squared plus x squared equals 8 squared. Just use Pythagorean theorem to figure out what the side is. So you get x squared equals 55. So this side is the square root of 55. So you can write the other two trig ratios. We already have sine, so we're going to write cosine and tangent. Just going to put the theta in there, this little circle with the line through it. Theta is a Greek letter. So cosine theta is adjacent over hypotenuse. So the adjacent side is the one we just solved. Square root of 55 over the hypotenuse was 8. And tangent is opposite 3 over adjacent square root of 55. So another example, very, very similar. This time they give us cosine, so that's adjacent and hypotenuse. So you fill those in where they go, and then you solve for the third side. So x squared plus 5 squared equals 9 squared. Subtract the 25 from 81, 56. You could actually, I think you can actually simplify that. If you do a little factor tree, that's 4 times 14. So you get a pair of 2's. 14 doesn't have any pairs in it. It's not a perfect square. So this is 2 square root of 14 if you simplify it. So when you write the other two trig ratios, we started with a cosine, so we need to write sine, and we need to write tangent, the other two. Sine is opposite over hypotenuse, and tangent is opposite over adjacent. And there's our two ratios.